When a nucleus is very big, it becomes unstable. It's a bit like when you build a sandcastle, and when you get a really big sandcastle, the last bit of sand just keeps falling off. That last bit of sand is a bit like an alpha particle. You put it in, and eventually, bang, it comes shooting out. So what is an alpha particle? How do we know they're there? What do they leave behind in the nucleus? These are all questions that we're going to try and answer. Let's look at how to build a really big nucleus first. You may not know this, but most of the most common atoms have a mass number which is a multiple of 4, and a proton number which is a multiple of 2. Let's look at helium first. Helium has got a mass number of 4, a proton number of 2. Now let's go on to carbon. Carbon has got a mass number of 12, and it's got a proton number of 6. So it could be made up of 3 of these blocks of 2 neutrons and 2 protons. Then finally, let's look at oxygen. Oxygen has got a mass number of 16 and a proton number of 8, and it can be made up of 4 of these building blocks. This is because the easiest way to build a bigger and bigger nucleus is to add 2 protons and 2 neutrons at the same time, just like this block here. So if you can imagine, if you've got a really big nucleus that's so big that it starts to become wobbly or unstable, and bang, out comes 2 protons and 2 neutrons together in an alpha particle. So there you have it. An alpha particle is 2 protons and 2 neutrons. It's the heaviest type of radiation, and the 2 protons give it a charge of +2. 1, 2. Also, because it's very heavy, it travels slower than other particles. Well, in particle terms anyway. They come out of the nucleus at 30,000 kilometers per second. You might find that a bit fast, but wait till you see the other particles. You can use these properties to detect alpha radiation. Because it is big and has a large charge, you can make it move through an electric field. So here's your alpha particle coming out of the nucleus, and it's going through an electric field. As it goes through, it bends. If it comes across another atom, it's pretty likely to take an electron with it. Here's the alpha particle, here's an atom. The alpha particle comes across it. As it gets near, it starts to make it wobble a bit, and as it comes away, it pulls off an electron with it. This makes it very, very ionizing. However, it also loses energy more quickly than the other particles, so it slows down and eventually stops. This means it's not very penetrating. You can even stop it with tissue paper. Once you stop it, it sits and waits for a couple of electrons. So remember we said it's got 2 protons and 2 neutrons? When it gathers those electrons, it becomes a helium nucleus, which is pretty harmless. So there you have it. An alpha particle is a helium nucleus, waiting for 2 electrons. What about the nucleus it leaves behind? This nucleus is called the daughter nucleus. This has lost 2 protons and 2 neutrons. The newly formed daughter nucleus loses 4 in its mass number and 2 in its proton number.